So welcome to the Nansen Neuroscience Lecture for 2024. Today we are celebrating Nansen's birthday to honor his fundamental contributions to science and particularly neuroscience. So my name is Lise Øvreås and I'm the president of the Norwegian Academy of Science and Letters. And I wish you a warm welcome today. So Nansen was born October 10th, 1861, so that's 163 years ago. And as you can see, we have a very nice painting on my right side of Nansen. It's an oil painting made by his son-in-law, Aksel Revold. And this is also an important painting in this room, so even when the door is open, you can also see this when you're entering the building. So this Nansen Neuroscience Lecture has been held since 2010 and are a part of the Academy's Nansen celebration. These lectures is a collaboration between the Norwegian Academy of Science and Letters, University of Oslo, and the Nansen Neuroscience Network. When Fridtjof Nansen died in 1930, he had accomplished several achievements in highly diverse disciplines. He assisted refugees, went on polar expedition, and got involved in the diplomacy. He also received the Nobel Peace Prize in 1922 for his leading role in the reparations of prisoners of war in international relief work and was the League of Nations High Commissioner for Refugees. His work on behalf of prisoners of war and starving people earned him the Peace Prize. That was indeed very important global work achieved by Nansen at the time. I think it's still with sadness that we see that in 2024 we still have dramatic wars going on in our close vicinity. And this Monday indicated 1 year since Israel formally declared war on Hamas after the Islamist militant group launched its deadly surprise assault. Nansen is well known for his work with refugees, for his voyages, scientific cruises, and expeditions. But he is also well known for his important pioneering work within neurobiological sciences during the 5 years when he was living in Bergen. So Fridtjof Nansen started his academic career at Bergen Museum. He decided to study zoology, as this could be very well connected with fieldwork and outdoor activity. He was appointed a museum curator in zoology and soon became part of a highly active research group led by the leprosy doctor and zoologist Daniel Danielsen and the microbiologist Gerhard Amøa Hansen, who discovered the leprosy bacterium. Nansen was early interested in organization of the nervous system in primitive marine animals, collected at Norwegian North Sea expeditions. And during his years in Bergen, he learned advanced methods for neurohistology. He provided, at the time, new and cutting-edge knowledge in how the nervous system is built and how it works. And he is recognized as one of the pioneers of neurotheories based on his PhD work. This represents today one of the important classic contributions to biological sciences. Today's neuroscience lecture will be given by Professor Ulrik Wisløff, a researcher and an entrepreneur in the field of exercise physiology, and is also the head of the Cardiac Exercise Research Group at NTNU. The Nansen Neuroscience Lecture 2024 celebrates Ulrik Wisløff's extraordinary journey of discoveries offering insight into the important combination of exercise training and cardiorespiratory fitness in health and disease. I wish you all a warm welcome and I hope you all will enjoy today's Nansen Neuroscience Lecture. And with this, I give the word to Linda Hildegard Bergersen. Thank you.
So welcome to this 14th Nansen Neuroscience Lecture. And it's a great pleasure to invite a Trønder this year. Last time we had a Trønder, after giving the talk and some years later, they got the Nobel Prize. So no pressure. And as already mentioned, Ulrik Wisløff, he's head of the Cardiac Exercise Research Group at the Norwegian University of Science and Technology. And Fridtjof Nansen, our polar explorer, neuroscientist, and diplomat that we celebrate today, share some similarities, despite their different fields of expertise. Both Wisløff and Nansen are recognized as pioneers in their respective fields of science. Wisløff has made significant contributions to exercise physiology and cardiovascular health, while Nansen was what we call a trailblazer in neuroscience in his early studies of the nervous system, and the reason why we celebrate Nansen in our Nansen Neuroscience lecture. Wisløff's work revolves around how exercise impacts cardiovascular and metabolic health. Emphasizing human endurance, Nansen, in his expeditions, was an example of pushing human physical limits under extreme conditions. And what did he do when he was at Fram or crossing Greenland? He was in isolation, in the extreme environment, and there is some similarities between you, Ulrik, and Nansen. I think that's enough. Yeah.
Thank you, and thank you for having me to have this lecture. I'm not sure if I deserve to be compared with Nansen, but let's see. So this is the title I got, and this is a title that is more precise in what I'm going to present, because what we are doing is we are doing translational research on physical activity, and we work with the populations, and we also work with different models. So what we typically have, we are so fortunate to have the Trøndelag Health Study in our university and our region, and we very often start out to identify a problem in the society, and then we have clinical studies in the same populations, and we also always have experimental models that mimics the human disease or human conditions. And of course we are also able to study organs and cells, and we have core facilities that help us out doing molecular analysis of what all research we are doing. So my background when I did my master degree was that I was working with Olympic endurance athletes and with very systematic training and high fitness level. And when I started my PhD at the Faculty of Medicine, I wanted to transfer these training principles from athletes to the cardiac patients, and I presented that to the cardiologist, and they said, yes, this is great, but you're crazy, you can't do this in humans. So you have to do it in rats first, and I had never seen a rat in my life, not a lab rat at least. But with help from Oslo, with Ole Seierstedt and his group, we made a model for heart failure, post-infarction heart failure in rats, and we also built treadmills for rats. And what we saw, we could test their fitness number, which is the cardiorespiratory fitness level, or maximal oxygen take. We saw that in healthy rats. If we induce myocardial infarction in healthy rats, their fitness level goes down. And if you exercise with, if you have post-infarction heart failure and exercise with moderate exercise training, you have quite good improvement in the fitness number, whereas those that with heart failure that exercised with high intensity had even higher fitness level compared to healthy inactive rats. And we knew already that cardiorespiratory fitness is the main predictor of current and future health, and that is true for normal subjects and also for subjects with already established cardiovascular disease. And so it's more important to have a high fitness level than it's a stronger predictor than if you have heart failure, if you are smoking, if you have hypertension, and so on. And that's a good news. This is good news and bad news. It's bad news for the couch potato that do not exercise, but it's really good news for patients with cardiovascular disease that becomes fit, and there's a lot of them in the society, so that's absolutely possible. So what our contribution has been is to to study different types of endurance training and see how that affect cardiorespiratory fitness or the fitness number. And we are able to isolate the heart cells or cardiomyocytes. So these are the cardiomyocytes contracting. And this is from a rat, but it's more or less identical in our hearts. And we can load them with calcium indicators, so we can see, or other indicators to see what are the mechanisms behind improved fitness level. And see if we can stop this. Probably can't do that. But this is mice running at 90% of her maximal oxygen take before training period, and this is the same mice running 6 weeks later. So it's quite easy to see that exercise training is working also in these animals. And this is the typical interval training protocol we use. So this is an example from an Olympic athlete. We have a warm-up period here. We have heart rate on the y-axis, and we have 4 times intervals with 2 to 3 minutes in between. And they're exercising at typically 90 to 95% of their maximal heart rate. And this is what we wanted to do in humans, but we did it in rats first, but we did exactly this. And this is an example from a cardiac patient doing the identical training program as the Olympic athlete, and the relative intensity is the same. Of course, they are not running, they are walking or running slowly, and this is how it looks when a patient is walking at 90% of peak heart rate. They're not running, so it's they're walking at 3 kilometers per hour or something like that. And this is how it looks. They're breathing quite heavily after each interval. So that's so if they don't have a heart rate monitor, you don't need that. It's the intensity should be that you can speak, but you can't sing if you ask them to do that. And what we found in this study was that those that trained with the highest intensity, they had superior adaptations mostly on everything. Here is an example from endothelial function and maximal oxygen uptake, which is the fitness number. Those that trained with a moderate intensity, they had okay improvement, quite good in fitness number. They had okay improvement in endothelial function or blood vessel function, whereas those that trained with the highest intensity, aerobic interval training, they had the best cardiovascular adaptations. And this study actually led to that we started to do this type of training also in patients in cardiac rehabilitation in Norway and also later on in the US. So we have compared high intensity to moderate intensity in different patients group. Here is a study that we did in patients with type 2 diabetes, where we saw that those that trained with the highest intensity, they had the most improvement in cardiac function, both systolic and diastolic function. In this study, we used intracoronary ultrasound to see what's happening with the plaque burden inside the coronary arteries in the heart, of course. And we saw that here both exercise modalities were more or less equally effective, but we had trends to that also high intensity had better effect. But this was a too small study, and we're doing larger studies in this using the same or an even improved technique now, actually. And also in patients with atrial fibrillation, which is a huge problem in the society, we saw that we did what was not recommended. We used, at that time, we used high intensity training to see if that could influence the burden of atrial fibrillation, and it did. And right now, we are running this was a small sort of proof of principle study. Now we're running a study in 300 patients that all have been included, and hopefully we'll have some good data to present in a year or so. And of course, we always get this question: is it safe for patients with established cardiovascular disease to do exercise training with high intensity? And we published that in 2012, where we had about 100,000 exercise hours with different intensities, and we couldn't see any the risk of event was equal and really, really low in both moderate and high intensity interval training in these patients. And again, back to the Trøndelag Health study, where we studied what intensity gives the highest maximal oxygen uptake. So we tested 5,000 people or 4,600 people, and we had their heart rate measured, we had the questionnaires of their training habits and so on. And we saw that those that exercise trained for 50 minutes per week, if they chose to do that with high intensity, which is the intensity you can speak but not sing, they had higher fitness number compared to those that preferred to train more than 200 minutes per week with low to moderate intensity. So you can get away with not that much training if you choose to do it with high intensity, which is important take-home message, because the most common reason not to do exercise is that people have, or they report that lack of time is the main reason. Also in the Trøndelag Hunt study, we saw that a single weekly high-intensity workout reduced the mortality, cardiovascular mortality, by 40 to 50% in men and women, which is much larger than any medical treatment can give, of course. And we saw that, again, if you trained many hours per week, it didn't help you anymore. But again, it seems like high intensity is the key. In 2012, we started the Generation 100 study, where we wanted to see if exercise prolong life in older adults. And this video summarizes those data, hopefully.
Can exercise really make you live longer? To find out, in 2012, the Cardiac Exercise Research Group at NTNU included more than 1,500 older adults in the longest and largest randomized controlled exercise trial performed to date, in a study called the Generation 100 study. 8 years later, we can finally reveal the results. For 5 years, one group of participants did high-intensity interval training twice a week. Another group exercised moderately 2 days every week. The third group were encouraged to exercise according to the National Physical Activity Recommendations. The participants met for a thorough health and fitness check at baseline after 1, 3, and 5 years. The results clearly show that older adults who are able to keep up a high physical activity level have a much lower risk for premature death than what is expected in this age group. Importantly, our data demonstrates larger health benefits in those who exercised mainly with high intensity when compared to those who mainly exercised with moderate intensity. We therefore suggest that future guidelines for physical activity, at least for older adults, should state specifically that at least part of the activity should be performed with high intensity.
Yeah, and some of you saw that the control group, they did better than the moderate group, and the reason was that the control group, they started to train as crazy, and they trained in between the moderate and the control group. So, and I did much more interval training than in the moderate group. So that's a problem in Trondheim. So this is a quite cool study that was published from some colleagues from Australia. They were following about 1,700 men that were aged 70 years and above, and they followed them for about 60 months. And what they did was they asked these guys to walk according to their preferred daily walking speed. That was the aim of the study, and then they followed them up, and they found that none of the men that preferred to walk faster than 5 kilometers per hour. None of them died during the follow-up period. So they concluded that the Grim Reaper's walking speed is probably 5 kilometers per hour. And that's fine, but we would like to know how fit is the Grim Reaper? That was a question that ATF, that is also here, asked. And then we used the Generation 100 study again in almost 800 men and women, aged 70 to 7 years old. We had a baseline test, and we let them train for a year. And then we follow up for 5 years. And this is a busy slide, and you don't need to understand much of this, but the bottom line is that if you are below 85% of your age specific fitness level, you are really at high danger of dying the next 5 years. And if you are above the 85% of average fitness level for men here, you are in a safe zone. Few of them died, actually. And we saw the same for women, but the take-home message is here that so when chasing souls aged 70 to 70 years old, the Grim Reaper seems to prefer women with fitness level less than 22.2 in fitness number and 26.5 for men. So if you are approaching 70 years old, you should look at these numbers and make sure you get above them. And in Trøndelag, we also would like to know more about the Grim Reaper's perspective on alcohol and fitness. And so we had this hypothesis that if you are fit, and fit is not super fit, we said that if you are above the 20% lowest or least fit, you are in the fit group. And we said that if you are among the top 80% people with the or highest VO2 max levels, you should be probably safe. But we didn't know that, of course. But what we found was that the increased risk of mortality due to alcohol intake was mitigated by in fit individuals. So if you're going to drink alcohol, make sure you stay fit. And also, we saw that changes in fitness was a better predictor than changes in alcohol intake over 10 years. So this is a study that will be published soon. So we dare to say that we have had a couple of decades with success with translational research from society to bench to bedsides and a mixture of all this. And this has led to that we have established this National Competence Center for Exercise Training as Medicine, where we educate the rest of Norwegian hospitals and healthcare personnel in how to do exercise training in different patients group. And it has also led to that the NOREC study, which is the largest randomized training study ever, that is going on, and we aim to include 9,700 patients with a previous myocardial infarctions. We have one exercise group that we follow up with our e-health program and some personal trainers. And we have two control groups. One get today's advice for physical activity, and one group do not know that they are part of the study. And that's based upon the problems we had with the Generation 100 study. That was not easy with the ethical committee, but we made it in the end. And we have about 50 hospitals with us across Norway, and we have already included 9,600 patients approximately, and we hope to have included all patients by within a few months, and then we just have to wait for 3 years to see the results. So what is your fitness age? What is that? Fitness age is something that we introduced based upon the Trøndelag Health study again. So we said if you are 50 years old and have the fitness level or the maximal oxygen intake of 30 years old, you have a fitness age of 30. And we have used this fitness calculator in more than 30 studies, and we have found that you can do this at home, sitting at home or in your office or here, and the accuracy of prediction is as good or even better than the Framingham risk score or European heart score. So and we have 30 papers published on this, and fitness is now regarded as a clinical vital sign, meaning that if you go to your doctor, you should have this measured, or that's not realistic. That's why we made this fitness calculator. So you should have it measured, or you should have it estimated. And the American Heart Association suggests that they should use this, the fitness calculator that is established by us, and you can follow this link, and you can do it in 2 minutes. Then you have an idea of your fitness age later on. And another thing we have invented in my group is the personal activity intelligence. The reason we did that is that it's not easy to understand for most people how much do I need to exercise in order to optimally take care of my own health. And because walking 10,000 steps or 30 minutes might be good if you walk uphill or if you raise your heart rate. And the agreement worldwide is that heart rate says something about or reflects your body's response to any physical activity. So again, we had the Hunt studies. I will not go into much detail about that, but we have data on 230,000 participants approximately. It's in 4 waves, starting in the mid-80s, and the last was in 2020, and the next one is coming. So what we did, we invited about 5,000 people. We tested their fitness level, their maximal heart rate, their submaximal heart rate, and everything on them. And we had the heart rate over 7 days, and we were able to make this scale from 0 to 100, and where we saw that those with a low or below 100 points per week, they had a clustering of cardiovascular risk factors. Those that had physical activity over a week that earned them more than 100 points, they had a good cardiovascular health profile. I will not go into detail about this, but happy to discuss and show you more later on if some of you are interested. But that was a good thing that we had this profile, but we also had, because we had the same data for people in Trøndelag back in the 80s. We went back to the 80s to plot this data for each individual, 20,000 men and women. Followed them via registers for 26 years, and we had about 10,000 deaths during that follow-up period. And we saw that those that managed to exercise weekly, so they had this 100 points based upon a heart rate pattern over the week, had increased lifespan by up to 10 years and also reduced the risk of several lifestyle diseases. And we also saw that the substantial effect if in people that already had overweight, type 2 diabetes, in smokers, and so on. And importantly, this is regardless of meeting physical activity recommendations, meaning that if you have 100 points per week, you were on the safe side, even though that you did not fulfill today's recommendations. So, and also if you fulfilled today's recommendations given by the health authorities, but you were below 100 points, you were not on the safe side. So it's a more precise way to guide people how to do exercise for health. And the good thing here is also that any activity counts. So measuring your heart rate is the key, and every heartbeat counts. And of course, we have not stopped the development of this, and we have now developed an even better metric that was launched this week, I think. So you can, and that's called, everyone knows the IQ and maybe EQ, but few people know AQ, and that's the new thing. You need to know your AQ. So that will be the new pi. But it's more precise. We have much more data on different age groups and so on, and it's NTNU and Sintef spin-off company that have been launching this, and for the first 60,000 downloaders, they had really good adherence even after 12 months. And normally adherence after 12 months is around 25 to 30%. So it's promising. Okay, and We have also been focusing on the brain the last years because we had ATF coming into the group, coming from the Kavli Institute, the Mosers, and if you look at the risk factors for cardiovascular disease, it's the same risk factors for dementia, and we think that cardiorespiratory fitness is the common factor, and of course we live longer, but we will live better. If you haven't heard of her, you should really Google her. It's a absolutely fascinating story about. I think she had a good life. Yeah, and according to the World Health Organization, they say we are in the decade of healthy aging, and we need to focus on how to add years to life, but also life to years, of course. We have to increase the lifespan, not only we need to increase the health span, not only the lifespan. And also the World Health Organization, they say that the life in good health has remained constant, meaning that we are spending the additional years in poor health, which is a little bit scary. And if you look at this graph, we see that there is not a aging wave, eldrebølge. It's going up there, and it's increasing. And this graph shows that we will have more older adults than before, but we will not have more health personnel in work. So we have to take better care of our own health. And there were some smart people some years ago. They said that in 2006, but they also said this, which is quite interesting. So many are waiting for the miracle medicine, but nature has already given us a good and cheap medicine that is available to anyone, now namely physical activity. So, yeah. And you can read yourself, but I mean, we can say this also in 2025, 24, 25. So nothing has really happened. And also the Lancet Commission from 2024 say that, of course, because we get so many more older adults, the forecast is that dementia and similar diseases will be the new public disease. And the Lancet Commission said that we can prevent a lot of these dementias if we focus on the 14 risk factors they identified, whereof education, of course, is high up, but also physical activity, but also this year physical fitness, or the fitness number. So that is good. So I will present some of the data we have on our brain health research and fitness. That is led mainly by ATF, Tari, and we wanted to investigate the association between changes in fitness and risk of incident dementia and dementia-related mortality. So what we did, we went to the population-based Trøndelag study, Hunt 1, and people that took part in Hunt 1 and Hunt 2, and we were able to follow them up through health registers, health and memory study, and so on, and also the cause of death registry. So what we saw was that people that remained fit here, they had about 40% reduced risk of dementia. They had delayed onset if they got it. They also had 44% reduced dementia risk and 2 years delayed onset if they got it. And what was depressing is that it doesn't matter if you were fit when you're young. If you decrease fitness over 10 years, you have as high risk of getting dementia and dying from it as those that stayed unfit all the time. But the good news is that if you were unfit, you can change at any age, more or less, or the sooner the better, but it seems like up to high age, you can increase your fitness level and have the same protection as those that remained fit all the time. And then we looked into what kind of dose do you need to do in terms of physical activity, and then we looked into the PI score that I mentioned earlier. We have the same design. Those that were inactive or those who were active all the time, they had reduced risk of developing dementia. They got 3 years delay of the disease. They had less risk of dying from it, and if they died, they died later on. And again, it doesn't matter if you were fit or if you exercised when you were younger. You have to keep it up. If not, if you're losing your fitness level, you increase the risk to the level as those that's being inactive all the time. And again, increasing from inactivity to activity give you the same protection as those being active all the time. So it seems like exercise is like it's like fresh meat. You have to keep it fresh. So the take-home message from these studies: keep fit, and here you have also a guidance through the PI score how much activity you need to do in order to stay healthier for longer. And motivated by this study, where old mice and young mice share the same circulatory system, they saw that old mice, they got improved memory, they got better communication between neurons, whereas the opposite happened in young mice. So young mice started to forget and so on. We thought that it must be much smarter to do, instead of using young blood, we could use young exercise blood. So that was the aim of this journey, I would say, that is not ended yet. So what we did was we established this cell model where we had healthy cells that we stressed with the amyloid beta, which is part of the Alzheimer's disease cascade. And you can see that the Alzheimer's cells, they don't behave very well. Then we had fit donors from our group that donated plasma. They had the fitness level of quite good, 63.2 milliliter per kilo per minute. And we also had unfit plasma. And you can see here that the cells, AD cells, that we call it, that got fit plasma, they became much better than those that actually got plasma from unfit donors. So that was sort of the start of this journey. Then we thought, okay, we have to do this in animals. So we joined with the Kavli Institute and got 80 rats from them. We exercise-trained rats, and we had sedentary rats. We injected the plasma into the tail vein of these rats, 80 rats. With exercised plasma, or sedentary plasma, or saline, and we did a lot of experiments. And the take-home message is that it's not easy to see this, but the take-home message is on top. We saw increased neurogenesis in the AD rat brain that got exercised plasma. So that was that led us to can't we do this in humans? And again, but this time we met clinicians that were quite positive, and we wanted here to see if we can have fit donors and give fit plasma to patients that have Alzheimer's disease. And this is what we used 5 years of our life to get approved. So now we are doing it. We have patients with early stage AD. We have fit male donors, and that donor give us plasma via the blood bank at St. Olav's Hospital. And we have 3 groups. One get exercise plasma, one get octoplasma, which is the regular plasma at the hospital, and one get saline. And we do blood samplings over the years 7 times. I will not go into details here. We do lumbar puncture, so we have for our biobank, we do a lot of cognitive test batteries at the neurology department. We do echocardiography of the heart to see that, or to make sure it's safe to do these transfusions, and also to see if we can see some beneficial effects on the heart as well. As a secondary outcome, we do MRI with the 7 Tesla or 3 Tesla if that's needed. We do, instead of the fitness test, we do the 6-minute walk test, because we don't know how these patients are in a year or 2 from now, so we don't want to have them on a treadmill. They get infusion 12 times during a year. I will show you the protocol here. So we have the 3 groups, and they get plasma once every week for 4 weeks, and then it's some weeks in between, and then we do this 3 times, and we do a lot of tests throughout the year, quality of life, cognitive tests, and all the tests I showed you. So, and the status for X Plus right now is that we have included 35 patients. We have 25 to go. We have been delayed by COVID, of course, but it seems like we are speeding up now. 2 of the patients, it's a double-blinded study, so we don't know what they have got, and they don't know what they get. 2 of the patients would not have been included as Alzheimer's disease patients after a year of treatment. So it's, and the neurologist that has been working with such patients for 30 years, she has never seen that, but we have no clue what these 2 patients got, so we just have to wait, but it's promising. And what's next? We are now looking into what can it be in the blood that what are the molecular secrets of exercise, because it's well established now that things that is released into the blood can cross the blood-brain barrier, and most of the molecules can do that directly or indirectly. So we're really looking into what can it be, and of course we have some clues from Linda and Jon's group, but I think this only scratched the surface, so we have to really do in-depth studies of many molecules. And to do so, we need much more information. We are trying to make a big biobank of MRI with many scans from the Hunt studies and the Generation 100 study. We have a lot of echo. We have a lot of CT examination. So we really try to understand the interplay between the heart and the brain in health and disease. And we also are establishing a cerebrospinal fluid bank based upon the X Plus study and the Generation 100 study, and we also have had user group meetings with the Generation 100 study, and they have agreed that we can establish a brain biobank. So that's what's on our list right now. How can we do it? How can we afford it? And so on. So hopefully we'll have people that have been exercise training for at least 10 years, because we still have 800 people left from the Generation 100 study that continues to exercise. They have been exercising for 10 years, and we will publish that study within some months. And what about Nansen? I'm going to conclude my talk. So he did his expedition, which is quite famous. But this is also part of my secret research, Linda. I've also done my expedition. I had a better boat than Nansen, but I didn't get that far north as he did. We did some experiments on physiological or survival in the cold. If someone would like to know how much it costs in terms of oxygen uptake, digging a snow cave, I have the answer on that. And so we have done some cool experiments up there, and I think that we share at least his idea of never stop exploring, and we also like it's easy to understand his fascination about the polar area. And these guys are the people that have been mainly behind the cardiovascular research part and fitness, and And lately, the last 3 years, we have established a new group under the SURG umbrella that is led by Atefe, who is here, that is focusing on fitness, exercise training, and brain health. So hopefully we'll have more data to share in a couple of years from these exciting studies. Okay, that's what I'm going to say.